Okay, everybody ready? Okay, FabAcademy 2016, week 12, molding and casting. This is probably my favorite assignment, making molds, casting with resins. And what I like about it is that it's very easy to access. Like nowadays, you can buy a cheap milling machine in the style of the modellas for very little money. For example, the other mill. The other mill is not exactly the cheapest one, but this is the one that is the commercial model of the MTM Snap. So it was developed by Nadia and Ilan at MIT. And other mill is from the other lab, and the other lab is based in San Francisco. And this is it. It looks exactly the same. Yeah, Andy just bought one, and he seems to be quite happy with it. Then we have machines. Then this is another machine that is already now in the second version. I don't like it so much, but the older version, you could very simply make it yourself by buying profiles from open builds. So this machine is also using these rollers. If you look here on the sides, you see that there are some wheels that run on an aluminum profile. And Open Builds is one of the distributors of this profile. And you see that there's lots of machines made with the same style of profile. And if you do it yourself, buying the profiles and a few pieces is quite cheap. It's like 6 euros per meter. So you could make yourself a little machine like this one for, I would say, about 300–400 euros, and you have a machine like this, which almost has the same quality than the Modella. Then you can also look like the X-Carve is another one in the same style that looks very unstable to me, but it's also quite cheap. Yeah, and then you have one, if you just search for 6040 CNC, you find lots of Chinese machines. You can get those for very cheap. You can buy a mechanical kit for just a few, like 300–400 euros. The electronics are very bad. And they're so bad that you should just like take them out, throw them away, buy new electronics and put those in, and then you have a nice machine for like 600–700 euros. I don't know why internet is so slow. Ah, hi Greg.
Hey.
Hi.
Could you invite Rafi?
Yes. Just a second. Where is Javier? This Javi? From FabAcademy? Yeah. Okay. So yeah, this is the Chinese model I'm talking about, and I find one with a bigger image. Yeah, it also comes as a 4-axis machine. The spindle is okay. The biggest size they have is 60×40, which is already quite nice. The mechanics are great, but the wiring is so bad, it's not shielded at all. So sometimes it's enough to turn on the spindle so that the machine starts moving a little bit. Also, the main board for the controller is so, like I read like a 20-page article about a guy that takes it apart and looks at each component, and he's just like ripping out his hair. It's like, what which insane person designed this machine. Looks like somebody designed something that has nothing to do with this machine, and then somebody took the same board and made a CNC machine out of it. It has some components that are not used on there. It's a complete nightmare. So yeah. So the easiest is to just take out all the cables and all the electronics and replace them, but then you still get a nice machine for a good price. And you can get, like, I think in Portugal I met somebody that bought it for $400, including shipping. And you can get it up to like something like this, which is already quite nice. So yeah, so milling machines are cheap and they're around for ages. Like this machine is 20 years old and it still sells for 5,000 euros. There's a lot about the durability of this machine. FabLab Amsterdam had this machine in use for 7 years. And this year was the first time that they opened and cleaned it, and it still works. And you can get results that are much better than 3D printing, and you can use any material. Like you can get hard material, but much more resistant than anything you can 3D print. You can get transparent material. You can get like glow-in-the-dark material in any color, whatever you can come up with. You can have material that changes color according to temperature. You can have material that is soft. You can have material that you can heat. You can have material that you can bend. You can have it out of foam. You can have it like there's a huge amount of materials you can use once you have a mold. And it's also great for making copies. So if you have a model and you want to make a duplicate of it, molding and casting is also the way to go. For example, we have lots of these connectors here. They're very nice, they're old connectors. Only problem is that we have lots of those pieces and very little of those. So I started making copies of those just by embedding them in silicone. Then I can cast them on copies. But if you try to buy those, not so cheap. But with molding and casting, you can make your own copies. You can do very small things. Remember Neil talking yesterday about models that are like in the micrometer scale. And you can do very big things if you have enough money for buying all the material. If you cast it in cement or in other materials, you can go very big for quite cheap. Yeah, that's a few of the things I like about molding and casting. And so for my assignment, I tried to make this motor. It's not a motor, it's a reduction for a stepper motor. It's a so-called planetary gear. And so I concentrated on one piece of it first, because the 3D printing, the quality is not good enough. And so I bought this block of wax, which I got in a jewelry store. This is the place to buy those things, because people working with jewelry use this a lot for making positive pieces. Then they also make a mold in silicone. Actually, in the jewelry business, they mostly use a process that is slightly different, where they don't pour liquid silicone, but they have silicone pads that go into a press that heats up. And so you press it under heat, and then it molds around your piece. And then you can open it, take out your original, and then cast copies in wax for using it in the lost wax casting process. You can also buy it already in small pieces, or you can buy it as a filament that you can use with a little pen, so you can like do 3D printing manually. And yeah, it's quite expensive. There's ways of doing your own using paraffin wax and HDPE, which is the plastic where the plastic bags are made from that don't make sounds when you move them. But it's a bit dangerous. If you want to have a look, or actually we can have a look at Maurici. No. Come on. Bruno Mauricio. So if you look at his week for molding, and I think it was for his final project. Oh, this, by the way, it's a very fun website to see. Like he has all kinds of funny stuff in there. I think, was this one? No. Oh. 9. Oh yeah. Okay, so there's a wide range of materials that you can use. In the end, he just made a little mold like this. Oh yeah, and here you see his own casted wax, which at this point wasn't so good. Let me see, this was 9, 10, 12, 14. Oh. Yeah, well, long story short, the wax caught fire while he was cooking it, and he did the right thing. He didn't extinguish it with water, which would be a complete disaster, but he just covered it with a board. But then he opened it too soon, and it kind of caught fire. There's a big cloud of wax vapor forming around it, and once he opened it, this cloud ignited, and with the explosion, he spilled the wax and it went over his hand. So he's going to have permanent marks of FabAcademy for his life, which is actually not so funny. But yeah, so if you ever do this by yourself, be very careful. Yeah, I don't know where he has his documentation on this one. Ah yeah, so this is his final project. So this is using the, maybe you remember, somebody asked, what is in the network and communication, there's one board that is called APA. And this is something that can communicate over the electricity line. And you can just connect many of those boards together. And his idea is to make an extension cord where one connects to the other. And you can connect the first one to your computer with a network cable. And then you can, by calling an internet address, you can turn them on or off. And so these are the boards. And here you see his self-cooked wax. This is probably before he burned himself. And here you can see the little pieces of plastic bag swimming inside. And yeah. Okay, and here, this was probably after already, so that's why he explains that you have to be very careful. Oh no, this was before the accident there. Yeah. Okay, so much on this. But he got some really nice results in the end. Yeah. So yeah, so Matt offers these waxes. This is where all our waxes come from as well. They come in different colors. The green one is the most rigid one, the purple one is the all-purpose one, and the blue one is the most flexible one. And we mostly have the blue one and some of the purple one. To be honest, for our use case, it doesn't make a big difference. Yeah, so since I only had one block and I wanted to do lots of things, I figured out in Blender how I would cut it. So I would cut the whole block once and then cut it horizontally twice, which is much easier in Blender than in real life. But actually, you can see that I accounted for the thickness of the blade of the saw. And actually, in the end, I managed to have the pieces exactly the thickness that I initially planned. My first attempt was for keeping it straight. I put some acrylic, which doesn't work at all. So second attempt was freehand, which took me about a whole day just for cutting those pieces. And now we have the big saw. I hope we can use it soon for cutting the wax. And I bought some special mills in the jewelry shop as well. They're very cheap. They're just €1 each. And they're perfect for milling the wax. You can see that the tip is very different from the ones that we are using. It has a very good chip clearing, and you don't need especially strong tools. The problem is that those always come with an axis of 3 millimeters, and our tools are made for inches, so they're 3.175, and those tools don't fit. They wobble around. And in my case, I built a little adapter for the modeller, so I could put a Dremel tool in there. Then I could take mills of any size. Yeah, I think we have a broken Dremel somewhere. If we had a lathe, we could adapt it to the monofab. But until then, we have to use the ones that we have. And so you do it in 2 or 3 steps. The first one on the left is the roughing. So you use something like a 3 millimeter mill, and you go quite deep and quite fast, just for clearing away the material. And it really starts from top, and it steps down, and it removes all the material. Then the next step is already a finishing pass. And the finishing pass assumes that the model is almost where you want it, and it only mills an offset from your finished surface. So if there's any big blocks left over from the roughing, the finishing tool doesn't know. It will just assume that there's only a little bit that it has to mill away. So if there's pieces left that are too big, you will break your small mill. And then I did the first cast. Since I didn't have so much wax, I made it a bit higher. You want, like the recommendation is to have at least 1 centimeter of silicone on top of material, because if there's only a thin film on top, the whole mold is too flexible, and you will never manage to make it will warp your model. So the top of your material should be about 1 centimeter under the surface of the wax block. Yeah?
I have a question on what you said just before about the rough cut versus...
I will explain this again in a second. Yeah, so this was my first attempt, and it's full of bubbles. You can imagine how happy I was. Wasn't happy at all. So the castings were also very bad. They were breaking everywhere, also full of bubbles. So I decided to build a little vacuum machine, and if you decrease the pressure around your mold, the volume of the bubbles increases, and the big bubbles, they float, and so they come to the top. It looks like as if it's cooking. It increases the volume a lot, doubles in volume, but then it boils down to something much smaller without bubbles. And since we're here, you might wonder, why do I have 3 cups? Why are they all transparent? And why did I cut the top of all of them? Any ideas? If they're any higher, they don't fit in the vacuum press. And if they're not transparent, you will be unable to mix it properly. Believe me, take transparent cups. I tried once in a non-transparent, and you mix it, and you think, oh, it looks good, and then you pour it, and you see it's all green on the border. So you really need transparent cups in order to see if you mixed it well. Because this one is blue, one is green, and so you can tell from the color if it's well mixed. And the mixing, like normally Neil says, once you think that you're finished mixing, mix it 5 times more. And this is no exaggeration. Like, the one thing that always fails is people don't mix it well enough. Actually, last year, only one didn't mix it well enough. But if you don't mix it well enough, it's a complete disaster, because it sticks to the mold, so you don't get it out of the mold. So you have to remill your mold, because your first mold is destroyed. I can also throw away the mold, because I'm not able to melt the wax, because it's full of silicone. So basically, you spend one day designing, milling, mixing, casting, or realizing, okay, you can just start over. Just because you saved yourself a minute in mixing. Stupid. Yeah. The other problem is, if you take too long for mixing, then it starts to harden, and you can't pour it anymore. So you have to be really quick mixing it, but you shouldn't mix in any bubbles, which is like 3 contradictions at the same time. So you will have to figure it out yourself, but rather go for mixing it too much than not enough. Because if you mix it too much, you can just throw away your mix and make another one, whereas if you don't mix it enough, you have to start everything over again. Yeah, by hand. By hand. But it puts in too much bubbles.
We don't have a vacuum.
We do, yeah. So, yeah. And they also have 3 cups. If you have 2 cups and you pour one into the other, first of all, yeah, then you have 2 layers sitting on top of each other. And for mixing those, you have to kind of scoop it. And scooping it is the best way of getting lots of bubbles in there. So this is why you want to mix them side by side, and then you can just shear it, how Neil says. Sounds very easy, but it isn't. You will get lots of bubbles in there just by mixing it, but doing it from 2 into 1 is already much better than trying to mix 2 layers that float one on top of each other.
In terms of time,
Oh, it's about 5 minutes that you have for mixing. 5. Yeah. Yeah, I think that's about it on the mixing. I use proper mixing sticks. I will buy Chinese chopsticks, which is the best. If you use like many people buy, we have lots of these ice cream spoons. They're not. You need something that doesn't break. You really have to put some force in there. Don't ever get the idea to use a piece of scrap wood or anything. It will break inside, and then it's not worth it. Get a proper mixing stick, get some proper transparent cups, and even if you have to improvise, it's not worth it. Like if you're like, oh, I don't have a transparent cup, or I just cut a piece of water bottle, it's gonna be fine. No, it's not gonna be fine. Don't save time in the wrong spots.
Also for baking, you often use a flat spatula.
For baking?
Yeah, like just a spatula rather than a stick. It seems like that.
Yeah. Yeah, this might be a good idea. But it's kind of it's quite big. Yeah, we can experiment, but it should be something that is very rigid and doesn't break. And then you see, next attempt, no bubbles. And actually for this one, as you can see that there's in the mold, there's very fine detail, not very far down, but like 10 millimeters down. So your drill has to have a reach length of 10 millimeters while being only like 0.5 millimeters thick. And this is very difficult. In my case, I took this tool and I put it into the drill press, and I used the Dremel tool for increasing the reach length a bit more. But that's kind of difficult to do, so I wouldn't recommend you to do a model like this one. Make something where your details are either very shallow or where there's not so much detail. Right now we have I would recommend you to use the 3mm mill or the 132 and the 160. No, the 1/8, which is the 3mm. No, the 116 and 132. So 0.08 and 3 millimeters. I think this is enough for most of what we can do. But I will show you this in a moment. Okay, so this is like the 3 steps. So you go from your wax mold to the negative in silicone to your cast piece in plastic. And then since it was the Fiestas de Lisboa and everybody's crazy for sardines, and my neighbor was becoming rich by selling jelly shots, vodka with gummy bears, I thought, hey, I want to make jelly sardines on a stick. You know, this jelly that is like all like neon yellow or orange and is alcoholic, and you know, the stick is in the mouth and the tail is just like. I think this would sell like warm bread, and you get drunk. Like, what else do you want? And here you can see that on my first attempt, it's a 2-part mold. two sides that stick together. And for aligning them, I made these little pins in there. The problem was that the distance from the pin to the wall is smaller than 3 millimeters. So my roughing pass didn't go here on the side. It just left something that looked like this. And then I did my finishing pass, but the finishing pass didn't know that there's like a 5 millimeter high block of wax in the way. So I tried to go just straight through there at full speed, which broke my milling bit, and it broke the pin, as you can see here. So whatever you do, keep at least 3 millimeters distance from the wall. Make it 3.4 or something to make sure that the mill really goes through there, and double check in your CAM program if the roughing pass leaves you something that is nice enough for a very thin tool to go through there. And then, since the wax is so expensive, I made my own wax. This is the roughing pass of my self-made wax. And this is the first molds. And you can see that for the bigger one, I changed strategy. This one is full of bubbles because it doesn't fit into my vacuum press. And you can see that this one, the border is a bit lower, and here the border is a bit higher. I will show you how to model this, but this is the perfect way for making the two match together without needing any special pins or anything. And this one I just put some screws in, but it didn't really work very well. Yeah? Yeah?
How do you know that it's enough?
Ah, yeah. Okay. So once you have your mold made, like the wax one, you either use your CAD program for calculating the volume of the empty space, or you fill it with water and pour the water into a cup and measure the weight of the water. And the density of the silicone is about the same density. You can assume density 1. So if you take just as much weight in silicone as you have weight in water, you should have the right amount of silicone. That's an important thing that you should do. If you're confident with your CAD skills, you could also calculate the volume and then multiply the volume with a density of 1, which is the same, and then you get the weight. And our silicones have a at least this one has a 1-to-1 mixing ratio. So you have to calculate how much you need of each so that it fills your mold nicely. It's better to make a little bit more than not enough, because if you have some leftover, it's not a big deal. But if you're missing some, then you have to do it again. Also for the pouring, so Neil recommends to pour it with a thin stream, because the higher you put it, the thinner your stream gets. And if there's a bubble inside, the bubble is, let's say, this big, but your stream is only like this thick, so the bubble doesn't fit inside. So it stretches the bubble until the bubble explodes just through the thin stream. The other problem, what Neil doesn't tell us, is if you pour it with a thin stream, you create bubbles where it hits the floor. This is why Neil tells us to incline the mold so that it hits at the deepest spot and then slowly fills for a little bit, and then I spread it with a brush or just with my fingers. Then I vacuum it for a short moment, so I burst all the bubbles that are directly on the surface of my thing, and then I fill the rest and I vacuum it again. And you leave it in the vacuum until, like, you can vacuum it 3 or 4 times. It shouldn't take longer than a minute each. So you let it boil up, and then once you release the pressure, many of the bubbles burst and it goes down again. And then you can just repeat it once more. If you do it in 2 steps, where you first put a thin layer, vacuum it, and then a second one, then vacuuming it twice should be enough. And you should account for the fact that the volume is going to grow a lot while you're vacuuming it. So if you're, what I usually do is we would need blocks of wax this high if we wanted to allow it to expand to twice its size. and we don't have this much wax. So what I do is I make it only the size of, I make it only that it's 1 centimeter above the model, and then I just glue some paper around it, just with some tape. So I make a border so that if it spills, it doesn't run into the vacuum machine. Yeah. You could also laser cut it in wood frames. Or, yeah. You saw that I used a little acrylic piece here for making the mold higher and some cardboard around it. And you could invent something like this. Making a little box around it is not a bad idea. And any more tricks?
So if you do the brushing and the vacuum and brushing and vacuum, this means that dry silicone sticks to wet silicone?
Yeah. It doesn't dry so fast. It takes about 10 hours for it to dry. If you put it in a warm atmosphere, it dries faster. So you can even have it ready in a few hours. But usually we just leave it, once you pour it, you leave it overnight the next day. And then once you start pouring your resin, make sure that you either have a resin that is compatible with your silicone, that doesn't stick to it. So the umu and the smooth cast, you don't need a demouldant. But I'm going to get some demouldant spray just in case. So you put a little spray of demouldant so that the plastic doesn't stick to your mold. You can also use a heat gun. If you're not happy with your surface finish, you can very carefully heat it up a little bit, but very carefully. Like I can show you some models. The one I showed you yesterday, if you look closely, you can see that it melted a little bit in some cases. So don't rely on the heat gun. Just mill it well enough, or make a design that doesn't need to be high resolution. I showed you the little statue. No, this one looks great, even though it's very low resolution. It's just a 3 millimeter. Good. And here's another example for a 2-part mold. So these are the 2 pieces for casting those silicone pieces. And those, again, have the border one lower, one higher, so that they fit together. And then you pour in the plastic for making one piece like this. And you see that if you have small holes, the silicone doesn't want to go in there, even with the vacuum. So what you have to do is you drill a small hole to the other side, and this way the air can escape, and you get filled holes. But doing something with lots of small little holes is almost impossible to fill. So avoid small holes. If you can't, drill a little hole by hand so that it can fill. And you should also think about air vents. So once you, like this one is missing something where you pour in the resin. I just cut something with a knife, which also works. But what you would want is one side where you enter with the material, and one side where you have some holes that rise to the top so that the air can escape. But I'll show you some more things. Maybe if we look at FabAcademy from Martin. So Martin, this was his model. And so he made one where the material comes in and one where the air bubbles go out. This is what it looks like. And here he included a fitting for pneumatics. And the idea was to actually I'm not sure exactly how he did it. Yeah, so he was using a technique that I invented last year, which is vacuum infusion. This is what people normally do for making composite models. You have a jar that is just 2 connectors, where you pull vacuum on one side, and you connect the resin or the part that goes to the mold on the other side, and then you suck over here with the compressor, and you feed it the silicone on the other side. So it will use the vacuum pressure for sucking in the material into your mold. This way you make sure that there's no bubbles inside, and you can easily get it into these small cross sections. So you see here is the resin, and here it sucks, so it pulls it down through the mold into the tube, and once it gets to the jar, the leftovers just go to the jar instead of inside the vacuum pump. That's what we need the jar for. And yeah, this one, and here he used a connector for the pneumatics, so he can properly suck. But he used this very bad double-sided tape for closing the mold. I would rather glue it closed with some silicone. But yeah, kind of worked. And here we go. Another one maybe interesting is from some people decide to simply make they want the silicone, not the plastic. And this is what Ronald did. So he wanted a silicone piece that looks like this. And he used the same technique where you suck on one side and you put the resin on the other. So here you can see it goes from the resin through the mold, through the jar into the pump. But didn't turn out so well. I think he also didn't glue it properly. And in the end, he just filled both sides and stuck them together. But yeah, he managed to make a piece. It does have some bubbles, but yeah, you should learn from the mistakes from last year. So don't glue it together with double-sided tape, but use some silicone or similar. And now I want to show you one that is spectacular. It's the Ninja Guide to CNC, no, Guerrilla Guide, sorry. So this is a very complete explanation on anything you want to know. It's a bit too much, so you can see how long this is. And it covers everything from modeling to what is a milling machine to whatnot. But if you click here on the I can now routinely crank out remarkably cool and precise designs in no time. And this one has some nice images. So he has features that are very tiny. This is incredibly small. And let's see if this works now. Yeah, kind of. Does it? Yeah. So he has a nice big milling machine. And the material that he's using here, this one is called VenShape. And VenShape is one of the brand names for what people know as chemical wood. And chemical wood is basically a polyurethane foam, but it's a very dense polyurethane foam. It's even more expensive than the wax, and you can't recycle it. But once you get a big piece of it, each time you make something, you can just mill it flat again, and then takes a while until you use it up all. But you can see how small his mill is and how long this thin part is. So you need some experience in like where to get those tools. And then this is his positive, and you see him casting the silicone in there. He also uses the vacuum for de-airing it, I think is the name for it. And then he just pours some resin. Guys, chatting outside. For closing it, so it's an open mold on one side. This again the silicone piece. And then this was just for closing the silicone. If you do something like this, please put demouldant spray on the other side, if not it will stick to your wood and then you're doomed. Whatever you do, put some demouldant on it. And then here he pours the resin, and then he takes out pieces like this. And they're like precise to like 001. And so he can make a small planetary gear in this size. And the pieces are super tiny. You can see how small they are. And here, this whole robot is only made, like this is all the silicone molds for making this whole robot. I don't know, but once you get into it, it's quite fast. And you can see how small the stuff is. So this would all be completely impossible to 3D print. No. Maybe with a Form 1, but then you wouldn't get all the choice in material, and it's much more expensive. Like those features are maybe 0.1 millimeters in size, and like there are 3D printers with a 0.1 nozzle, but no way you get anywhere close to this. And I tried, believe me. Yeah. And if you look through this page, it's also very interesting. Like he describes all the, he uses Rhino for modeling. Then he explains that we can't have any undercuts, like places like this or like this. Then he explains what the quality features of a milling machine are. So it shouldn't wobble like this. Actually, it's called. There's a proper name for it. I think it's called the runout. So you don't want runout on your spindle. And he explained what the different, you remember the conventional and clamped milling. This is all very nicely explained here. He also explains like this, some milling machines. He also has the 320, the Chinese one, the iModella, and lots of others. It's a very nice list. Then he explains, like this is the reach length. This is the critical factor for us. The shank diameter is another critical one. Since all our tools are in inches, the diameter is 3.175. Then you can have square end, ball nose, or corner radius. And this is what happens many times. So we do want to give an angle to any vertical walls where we can have an angle, so we don't run into this problem. Then this is the way you would measure if your tool is running around. And yeah, he explains a lot more. Shows you what the cutters look like at the flutes. Cut and come. Talks about cut programs, about come programs, about NURBS, and it's very interesting. Also explains some things that we know already, like the dog bone fillets. He explains how the mold is made. Explains some basic modeling features. And you can see that he uses the same, and in this case it's just a one-sided mold. Different milling strategies, step downs, conventional cutting, clamp cutting. This is, I think, where he explains the chemical wood. No. Yeah, things to avoid. Yeah. Have a quick read through this. It's going to take a while, but yeah, look at this. Like this is 1 millimeter. So this is very, very tiny. So the radius is probably 0.4 or less. I think at some point he has a video of the little motor running. So most of the things we do with little DC motors are limited by the torque of the DC motor. It spins very fast, but it has very little torque. And so what you want is a little reduction gear. But those are mostly kind of expensive and not always easy to get. So having the possibility to make them yourself is great. Then you get something like this. This is probably already strong enough that you can run something like, yeah, you can run the robot with it. Okay, and yeah, and there's some more photos of his little robot. Some explanations about gears. If you want to make gears, use SolidWorks or talk to me. If you want to do it in Rhino, you have to go through all of those things which you may not want. But then you can also do crazy gears like this one. Those are very handy if you want to change the direction of your rotation by 90 degrees. And those are great for getting a big reduction. That's called a bevel gear, and this one is called worm gear, exactly. And gears with straight teeth normally make more noise, but they're more difficult to mill. And gears with like inclined teeth, they only touch in a point. They're a bit more quiet, but can't take as much load. And you can also do something which is self-centering, like the extruder on the 3D printer. So yeah, that's a nice gear, but it's not easy to make if you don't have a 4-axis milling machine. And yeah, so I think there's a little video on the, oh no, I think it's on this one. Yeah, here you see how small the pieces are. And it's nice transparent material, so you can even see the inside. Oh yeah, and maybe you remember from yesterday, Neil talking about somebody in Tablet Barcelona that tried to cast with transparent resin. This was Thomas. And Thomas didn't use the proper, he probably just used the normal mask instead of the mask with the filters. And it doesn't harm you on the first time, but you get, what happens with like epoxy and most of these resins that are kind of epoxy based is that you get more sensitive to it each time that you get in contact with it. So the first time you get it on your hands, you just wash it off and you think, oh, that's okay, nothing happened. The next time you get, you touch it, you suddenly get a huge rash, or like your whole body gets crazy, your skin turns all red. And Thomas, it's enough that he smells it. Like, and each time you get in contact with it again, you get more sensitive. So now he's at a point where it's enough for him to smell it that his whole skin turns red. So yeah, even if it doesn't hurt you just touching it, be aware that it gets worse. So read the instructions for the resins. Don't trust on me. Read them yourself. And if you see something that you don't like, tell me. And so don't let this be my responsibility. You should all know how to treat chemicals, read the instructions, and protect yourself. And if you see me doing stupid things, tell me. Like I'm not. I do stupid things a lot. Come on, we want to see it roll here. This one has a motor in each side, so you can drive it like a tank. You can rotate on the spot, but it can also like rotate like this. Yeah. Okay. Yeah, it's a really nice. This almost looks like a render, but no, it's actually a photo. Okay, so much on that. So now we know that we want to do something small, because if not, it's going to just take a lot of time, and if you fail, then you just take a lot longer. We know, no, we don't know yet how to make the mold. So let's make a mold together. Okay, so I'll quickly just model something so we have something to play with. Let's say I want to make, what do I make? So this time I'm using, I'm cutting away half of my model. Now it's open on one side, but I can use the mirror modifier. So it's symmetric. Now if I continue modeling, it will automatically reflect the changes on the other side. So maybe we'll make a little spaceship or something. Oh. Hmm. Not the coolest spaceship yet. Okay, let's assume that this is a spaceship. Maybe I can. Oh, no, I did something wrong. Okay, never mind. Let's assume that this is something that would fly. And, okay. Let me just get it next. So this is our model, and this could be anything you came up with. And so what we want is a box that where our model fits in. To make a generous box around it, I can make it a bit smaller in this direction. And now I want to make it a bit lower. And I want this distance here to be about a centimeter. But now I'm not working on scale, so I just ignore this for the moment. But you can always scale your model afterwards. And then I give this one the ball. So I extrude it a little bit, scale it a little bit, move it down a little bit, maybe until I can get under this. Actually up to half. And I make it a bit smaller so that I get this chamfered edges. And now I have this on the bottom of my thing, and it needs to be a bit bigger. And actually, if I look at my model by itself, you will realize, ooh, this is not easy to cast, because, or let's make it even worse. Let's add a modifier for making it a bit rounder. And now you will see that the line at which I would have to split my model is not a straight line, because here, if I look from the front, this, oh, it's hard to see. This part that is kind of round, I would have to split it here in the middle, but then here it's a bit higher. I would have to go and split it here. So I would have to model a separation plane. So I add a plane. I subdivide it a little bit. And I move it here. And I look at my model and I see, okay, if I split it here, which I have to because I want to lift the top part up and the bottom part down, then I don't reach this part. So I have to look from the side and edit my model, make something that goes a bit lower here. And actually over here as well. And I see, okay, here it changes. So I would have to move one of those points over here, further to over here. And if you look at most plastic parts that you find, one has a seam somewhere. This one they clean it quite nicely, so you can see it. Oh, no, actually you can. Can you see that there's a line here? It's a curve. So now we know that this was made in the mold that opens and closes like this. Or on the mice it's always difficult to see, but let's see, find another plastic part. Ah, yeah, this is a nice example. So this is injection molding, and you can see the seam here. So this is also a two-part mold that opens and closes like this. You can see the pieces where the plastic was injected. You can see those spots, which there is something that pushes out the plastic. Because in injection molding, your pieces stick quite hard inside the mold, so you need some pins for pushing it out. Those are those that look a bit dull. And so this is a mold that consists of two parts in the middle that open and close like this, and one mold on each side, making all of this. It's already a four-part mold. That's something as simple as that. And if you look at things like this one, it gets much more complicated. So here I can see a seam, and here's also the seam. Like, take a plastic piece you can see around you and try to figure out how you would have to put it into a mold. Once you get there's some people that do some clever tricks for making a flat. It's almost on two sides, but this one is made in a mold where you have to screw out a piece of the mold. Another trick. So for mold making, if you're interested, I can give you some books on how to make injection mold. There's many tricks of so-called sliders. It's pieces that you push inside the mold, or for getting features. For example, this click here, it seems to be something ridiculously simple. It's incredibly complex. Because this one has an overhead. So first you can't mill it. So they do what they call EDM. So you make a tool that has the shape of a negative, and we use something like inverse welding for punching it out. And this one also needs a slider, because if you have this piece alone, not get it out. But this you can do in 2 pieces, but you won't ever get to this so it makes thick. So you have to have another little piece that slides in here, and if you look very carefully, you can see that there's still the seams visible from the slider. In this case, it's also a round slider, so you can just screw it straight, but you have to like turn it in, inject your part, turn out the sliders, and then you open the mold. Yeah, this one is easy. It's just a 2-part. No, it's a 3-part, 4-part mold, but you also have to get the interior. Yeah, it's very, very interesting to see. All those little pieces that are also inserts, when you change the date and the production time. So this is like super high tech. You wouldn't expect it, but it is. And so looking at my model, I would have to like move around those points until I find a so-called parting line. The parting line is the surface that splits your 2 molds in 2 parts. So this looks kind of acceptable. In SolidWorks, you have a test that you can run, so it shows you in different colors if your mold can actually open or not. Maybe do a quick called draft check. Also, if you do, draft check. If you work in injection molding, you can't have vertical walls. All your walls have to be at least 1.5 degrees inclined, because if not, it doesn't come out of the mold. If you do aluminum casting, you need at least 3 degrees of, well, if you do gravity casting, you need at least 3 degrees. If you do injection aluminum, you can go lower to 1.5. But, oh no, wait. Let's say SolidWorks draft check. So here you can see pieces like this one, and it shows us, okay, everything's good apart from those red thingies because they don't have enough draft angle. And yeah, here's the same thing. If you do a draft check from one side, you can see that 1/2 would be okay, but this red part here, you will have to get rid of it. Same thing on this one. So yeah, this is very, very helpful. Yeah, this one is a complete failure. This is just a quick explanation of the draft. So undrafted is 90-degree walls, and in this case the drafted version has like 20 degrees. You don't need draft angles because we're working with silicone, so it's easy to get it out of the mold. But you should know that a piece like this one would have a draft line that would follow the green, between the green and the red. This is where your parting line would go. SolidWorks has a function for automatically finding you the parting line. If you do it anywhere else, you will have to find it yourself. And it also gives you functions for having these. For example, here this might be a cell phone case or something, which has this little snap thing, and each little snap has to be a separate piece that is movable in the mold. So it gets very complicated very quickly if you're doing molds. Here you see beautiful model, and between the green and the red is the parting line. Or maybe just one more picture for showing you the parting line. Yeah, so you can see that this one has a quite complex parting line. It's the blue one. This one has a very complex one, so it would probably go from here to up there, then over here, all around, over here, jump up there. So if you have a complex piece, finding the right parting line is difficult. And here you can beautifully see the parting lines. And in this case, it's not flat at all. It's all like crazy. So in this case, I would be happy with something like this. So I would take my 2 models and put them back into my mold. and I would replace the floor of my box with a parting surface. Let's assume for a moment that I did this already. Or should I be, am I good enough for doing this quickly? Oh no, this is going to take a while. So let's assume that my model has a flat parting line, which is this one. And then I would make a copy of this one. Actually, of both. And on one side, I would rotate it in the y-axis by 180. And on this one, I would extrude it another time and make it a bit smaller yet and go down a little bit. Whereas on the other one, I extrude it and make it a bit smaller and go up a little bit. This way I make sure that my model, that my two molds fit together. But this one is much bigger than the other one. Does this make any sense? The two things so that it fits? Yeah. And it's also a good idea to model yourself if I have, let's say that this is my little tool. Okay, so this is my milling bit. And I would just model it exactly the same the size it is. And I would look if I can reach all the places without bumping into the wall. So I look here, yeah, this works. It's close, but it works. And I also have my 3 millimeters here. And I can go all the way around my model without ever bumping into obstacles. And here I would see, no, this doesn't work. I need more space here. It doesn't fit inside. And yeah.
Are there programs where you also select the tool that's already
Yeah. Yeah, I will show you. But it doesn't do the collision check for you. You have to.
What program?
I will show you. Just another while. Yeah. So this is kind of what you want. Maybe not as deep as this one. As I said, like 1 centimeter is enough on top of it. And yeah, you should have enough space, at least 3 millimeters around it, that your roughing gets all the parts. You should make sure that your tool doesn't hit the walls nor your model. And you should have the parting line so that you can open the mold in 2 directions without. Well, actually, you won't get the silicone out if this isn't the case. And then I would just, I would apply all my modifiers here. And then I do a Boolean join. And I join this one with my piece. And it disappeared. Great. Is it here? Intersect. What? Oh. What? Okay. So what I sent to the milling machine is just one mesh. It's not several pieces, it's one completely joined mesh. And all the vertices are together. So if I go here to the very corner, actually I should, if I go to mesh, faces, triangulate faces, then I see that there's all kinds of, lots of triangles in here. But they're all together. So if I take one here at the corner and I move it, it's all together with my mold. There's no hidden geometry like behind it or anything. It's just one nicely closed mesh. You should also do the draft check, Shift Control Alt M. And I see, okay, I have some mistakes here, and I would have to go and investigate. This is from the mirror modifier, didn't close it properly. So if I go very close here, I can see, well, actually this here is open. There's a hole. You see? So I would have to merge those together, which I could just do by either selecting the two and then saying merge, or I use the snap function for vertices, and I put the there's a function that is called auto where is it? Auto merging. Whoops. Mesh. Auto merge. Now we can just like snap one on top of the other, and they will automatically merge. So now if I do the draft check, the check is also fixed already. Okay, so much on that. And let's say I export this one. So I go File, Export. You can export it as OBJ or STL. What? Oh. Okay, it has some kind of problem. I don't know. Did it make an STL? Maybe we should have made a more simple model that we're actually going to mill. But let's have a look like this. Is there an STL? No, there isn't. We'll just do a very brute force remove doubles, and now it should be okay. No. Yeah, for some reasons it doesn't like my STL. Maybe because there's still some non-manifolds. Still. Okay, now it's clean, and I do port. Okay, I don't know what's wrong. Oh, come on. Sorry that this takes so long. Haven't had this problem before. I would want some name. Okay, it doesn't want, but maybe if you make a new file. Like one thing that I've been trying for ages is to make a mold of Suzanne. Maybe we can just pretend to make a very bad one. The problem is that Suzanne has lots of undercuts, and also the eyes, if I do the draft check, I see that the eyes are actually not joined to the rest. They're like separate pieces. So you would have to delete the eyes. and just, for the moment, I will just close them. Which is not the nicest thing to do to a monkey, but okay, let's say that this is my new model. And you can tell the draft line is going to be very difficult. It's going to go somewhere through here, and through here, and then maybe down here again, through the ears and up. But then you can't catch this part. So this is at least a 3-part mode for making this head. Let's just pretend that maybe I can just like do something like this. And let's just do the face. So I would have to delete some more stuff. Oh. Yeah, as you can tell, it's not that easy. So I delete a lot and it's still not working. Oh, come on. Okay, so this would work. For Suzanne. Okay, let's say that this is my model. Sorry, that's a bit weak, but so again, I make my box. The model, in this case, the parting line is almost okay. And I boolean them together. I remember that this one is called cube. So union with cube. Right. Okay, it's clean. And now I hope the export works. Desktop. Untitled. Oh, I don't know what's wrong with my Blender. It doesn't export STLs. Sorry? Yeah, you always need the positive. You don't need to model the negative. The negative is what the mill does for us. Let's save this Blender file. Oh, it didn't even want. I think my hard disk is full. Okay. Just a second. Maybe if I just delete the waste bin.
So then when you did the scholarship, the reason you had a little bit up and a little bit down is so that you're making a mold for a wall, a wall that's not solid.
solid.
I didn't understand a little shrinking and going a little up and a little down.
So if you have this piece, for example, tires, you want this one, you see the parting line in the middle, you open your mold like this. This mold is different because this one opens like this. You could open it like this as well, but here you have this texture. This one wouldn't allow you to open it like this. So you would either have to go around this texture or you form it in a different direction. You may have undercuts. So your parting line was from your model, what do you say? If you look from your model, if you look at the model from one side, you have to see. Actually, this here with the like if you look at this little soldier, you can see that there's one mold that goes up to this line, and everything that is there has no undercuts in this direction. So you can pull away the mold in one direction, or you can mill it from one side without having undercuts. If I was milling from this side and I wanted to get here, it's impossible. I can't get there, an undercut. So you have to choose your parting line so that you. Let's have a look at more parting lines. No, undercut has nothing to do with shrinking. Undercut is, if you look at this one here, oh, it's repeating. Come on. Come on, please be there. Yeah. This is an undercut. And this is an undercut. Does it make sense?
Yeah, I understand about the undercut. It's when we took the model and made it smaller, and the other side you also made smaller like that.
Yeah?
Why did you do
Oh, this is something else. This is just for making two pieces that fit together. So if you make a mold and you want, I think they're called registering. So many people put either some screws in there. So once you put them together, they can't move one against the other. Here you see that they put in lots of little spheres. So once you put the other side, they fit exactly together. So you can also see those little indents are the registering pins. But this is only necessary if you do a two-part mold. Yeah, it's just for aligning the two pieces. But my favorite method of aligning them is to make this border around it where one border sticks out and the other one goes in. Look at those models. Those are actually very nice. Like they don't have the centimeter difference to the top surface, but it's okay. I think you do something on top to gain some height, because the practice is so thick. Here on this one, you see the method with the pins. If you decide to go for this one, it's okay, but make sure that you have the right distance from the wall so that your 3mm mill can go all the way around them. But to make pins, keep 3mm distance around them. Or you do it like this one, where there's one wall that sticks out a little bit, and one wall that goes in all the way around. So once you have a negative of those two, they stick together perfectly, and they don't misalign. So this is my favorite one. This is also nice and rounded, but you can also make it square. Can you see this one? This one is the one sticking up, and this one going down. So here the shadow, you see that this whole border is raised above the model, and it fits together with this one. Same thing for the sardines. You see this one is sticking out, and this one is going in. But of course you can also do it with the pins, and then you put little screws on both sides to align them to each other. This is the method with the pins, but I did the mistake they don't have the 3mm distance to the wall. So you will break your finishing mill if the roughing mill didn't remove this material. And this one has the border. Yeah, and here you can see the parting line. So the parting line is the line, and the parting line was here. Parting line, does this make sense?
Only, I think the reason I was confused is because when you were disaggregating the outside wall of the building, I thought it was inside and everything.
No, it's just the outside. Yeah. Okay, so let's have a look at how to do this with the Fab modules. Did I finally manage to export something? I didn't, no? Maybe I'll try as OBJ, see if this one works. Ah, no, it was my space problem, exactly. Yeah, probably I didn't have any space, so this is why I couldn't export. So I'll try again on the desktop. No. Unknown location. Ah, no space left on device. Okay, so I still have a space problem. Did I empty my trash? Yeah, trash is empty. Okay, I have available 0 bytes. That's not so. I have a problem that I have a solid state disk which is very small, and I also have a problem with my swap drive. Anybody's interested? Yeah, I have. Oh. Yeah. Oh, sorry, this is embarrassing. Where do I delete my stuff? Just a second, I think I can delete this. Yeah. Oh yeah, let's do a little break. In the meanwhile, I can clean up my crap here. Come on. Yeah? Yeah, I wrote down the link you gave me. That's very interesting. Yeah, yeah, that would make it much cooler. Okay, 100 megabytes should be enough.
Oh, that's small. Yeah. Files but also you save it as different file extension and then you can press on it and go to your drive and download.
Ah, es la tercera. Comencé una de zona.
You can also sit up there. So if you see it in the kettle, it looks like this. Actually, I can show you one. The microwave and most ovens and stuff, they also have one. So it shuts off when it gets too hot. Yeah. It's not the thermostat, it's just the emergency shut off. So they look like this. And if you open them, there's a small little piece inside. Yeah, this. This is the piece, and this middle piece snaps up or down depending on the temperature. So those you should get them quite easy. You know, when you go out to the left, first one to the right, up to the gas station. Behind the gas station, there's the old metal, but they bring all the stuff from the shopping carts. I'm sure you can find an oven or a water kettle, and you can take out this piece, and you can take out the B metal in there. If you search for just for B metal, it's a bit more difficult to get a nice one.
Yeah. I saw some other thermostats, they have like inside this thing.
Yeah. Yeah, that's the same principle. And but getting one in a custom size is difficult. Mostly you get them already in a housing, something like this. But yeah, water kettle, ovens, thermostats from the heating. Yeah, this might.
This one?
This one?
No, it's like
I don't know.
yeah.
Yeah.
Anyway, thank you very much.
Yeah. Good luck. Okay, should we continue a little bit? Okay, so maybe I'll get back to the motivational part for a second. So one thing that I really want is a mold for making the handles for the cafeterias. I have at least two at home that are broken, and I bet you can just like Google for what's the Italian brand name is Bialetti. So Bialetti. I'm sure if you find like a nice view, you can just take the image, trace the lines. You can take measurements from here for knowing the thickness and the distance of the hole. I also have a broken one at home that I can bring tomorrow if you want. This would be very useful. Another very useful thing is the gaskets inside, and they burn quite easily. If you look for sorry? Yeah, hopefully. Yeah, so this one. Yeah, she didn't put much more documentation on this. But if you look on her website, you can find the coffee. Well, there's definitely an explanation of how she made the gasket for the espresso machine. And then another thing, if you look for the comic book stores, the typical comic book store has lots of these little action figures. You know those? Like this is like high-end molding and casting. If you have some comic figure or something like this, if you want to make copies, and this like something like this, you see those? Those are quite easy to make. In Portugal, we had a girl and she made a mold for one of those that she did in roto casting, so it's hollow inside, and she just cranked out lots of copies, and she painted them and she sells them for quite a lot of money. And if you're lucky, it turns hip, and suddenly everybody wants one. So with some luck, you can make. And I think there's a whole bunch of little figures that are like hip right now with the kids. So yeah, there's some complex ones and some that are very simple. Yeah, so this would be one recommendation, like look for like action figures and stuff. Then if you look for something like ice cube trays, oh, well, Google knows better than I do. So you can make your Batman ice cube trays, or maybe I should spell it right. Then, oh, letter pi, ice cubes, and here like a little, you know this little guy? So you can make a mold like this. Oh yeah, Space Invader ice cubes. Woohoo! Then I saw one with a Titanic. So if you pour it into you have a little Titanic in there. You can make like more complex ones. Little ghosts, little cats. Yeah. We can do this with the food safe silicone. Or if you want to have a nice present for your girlfriend or boyfriend, or you want to use some Voronoi ice cubes. Where's there was one with a skull. Oh yeah, Darth Vader. Last year, the guys in Singapore, everything they did was related to Star Wars. So this is just another idea. Oh yeah, chess ice cubes. Oh, how cool is that? Yeah. Oh, the Tetris ice cubes. Yeah. Oh, this is the Titanic one. So you can have a little sinking ship in your... Oh yeah, of course. Han Solo, the Han Solo ice cubes. Oh yeah, one thing, if you make ice cubes never freeze transparent. They normally get this kind of color because there's little air bubbles. But if you move the water while it's freezing, it turns transparent. So if you put your mold into the freezer with a little servo and a battery that always moves it a little bit up and down, so it like wobbles forth and back. This is the way that, you know those that look like a little shot glass? They're transparent. They actually grow on some sticks that are cooled, the cooling liquid, and the whole tray is moving, so they freeze transparent. And then in the end they heat it a little bit so they can pop it, it's all automatic. Okay. Yeah, so I think ice cube trays is very easy. So if you want to play it easy, or you can just like put a cable outside and just smash it closed. Take a thin cable. Oh yeah, the brain. Oh, I always wanted my brain soaked in alcohol. Oh yeah, then of course, gummy bears. They move the water. Yeah. So yeah, all kinds of candy. And you can also cast, like if you mix sugar with a little bit of you add some gelatin, you get something more like this. You can also melt gummy bears. If you put them, like once I forgot a bunch of them in my tent. Yeah, you get one mesh. Like, I left a bag of gummy bears in my tent at like 60 degrees inside, and they melted into one beautiful colored block. I had to cut it in stripes. So yeah, this would be fun. Like nice little molds. Whoa. Oh my god. Okay. Yeah. Don't overdo it. Okay, gummy bears, ice cubes. I love paso paso paso. Or my studying pazuquinha. So those little things here are super yummy. They're made out of 90% peanuts. They are delicious, and you can give them any shape you want. So the little N you see, this is the mold that we made for the pazuquinhos. So basically anything you can like press into a shape, you can make a mold for it. And I have another here. Okay. Yeah, we just found the model, and we're moving into a new house, and we're missing one of the feet for the bathtub. It has like a little piece, which is this one. So this is also a perfect example for a nice mold. Then maybe some finish. So for his molding and casting, he made those pieces that are for sailing. You know those? So this is also a nice little mold.
What is that?
Those are pieces for a sailing boat where you want to attach the ropes.
That's great. Produce injection in DIY.
Yeah, it's very close to injection molding. So if you ever want to do injection molding, this is the way to learn how to do it. And for Airbus, Airbus came to us for a 3-day workshop, and they have 500 tons of carbon fiber garbage every year. And so we brainstormed together what to do with it. And we made a mold for sunglasses. This one I made one part stick out a lot, so that just the parts and the neck can fit together. And you could put in pieces of carbon fiber and put some epoxy inside, and then you press it close until the metal is spread out, and you put that carbon fiber sunglasses.
Are there some traces that you should leave?
Oh, and for the flat tent, they made some flat bracelets out of rubber. So this is the outside one for adjusting the size. And this was another piece that we used the resistant silicone for making little metal pieces on the outside the mold. And this was an attempt to make new houses for the bees. So this one was casted in wax afterwards. And so if you take the wax, you take the honey from the bees, you take part of it also. And so normally they give them back like injection molded wax piece. And this was an attempt to do this for the green tablet to make all the process. And on the other, in this one, you see that the other side is used for making the piece that I showed you, where on one side you connect a vacuum, and on the other side you connect a jar to the silicone. You some here and wax in. But yeah, you have to glue them completely together, and you have to make the connectors so you can put the magnetic inside. You just rotate them.
How do you leave some kind of like escape traces when you press?
Yeah.
Because
you always need some air escape holes. Yeah. So maybe on this one, no, he also didn't do any air escape. But here you can see the channels for casting it. So he casted those in one piece. So this is the holes where you can pour in your liquid. Vibrating your mold is also a good idea. So he used an eccentric grinder just as a vibrator. But you can also just like strap a drill to a board and put something into the drill that is very eccentric. Once you turn it on, it goes and this is a good way. But tapping it with my hand is also a good way. But we have the vacuum, so it shouldn't be a problem. And yeah, so you can cast pieces like this. Also, if you look for the what do you call those plastic toys that you have to plastic plane kit maybe? Yeah. So if you want to go and do something cool, then this would be the direction to go. Also beautiful is, for example, if you do a clock. So if you look on Thingiverse for clocks, something like this could be one mode, and you could make all the teeth and all this stuff. Actually, mechanical clocks are quite nice because they are mechanically powered. And I'm sure you could do something, for example, something like a watering system. Let's say you have some plants that you want to grow in the middle of a field far away from any water supply and no electricity, and you want to water your flowers once a day. You could give it a big deposit, and the weight that you have to lift up, that runs through a pendulum, and this would run a timer, and each time you get to the right time, it would open a valve and water your flowers. So mechanical clocks are very interesting. I would also recommend you, and there's many models on Thingiverse. So you could.
Retraction.
Huh?
Retraction. What is received?
No, almost none.
Yeah.
Yeah.
That one yesterday, I never put yesterday.
Yeah. No, the stuff we have doesn't shrink almost. Like neglectable. Yeah, look on Thingiverse for clocks. There's many very easy ones, and all you have to do is lay them flat on a plane, and you're done. Just on a side note, so this one, if you search for how does a mechanical clock work, this is a beautiful video explaining how a clock works. So this is running the spring. So you have to wind up the spring, which is equivalent to the weight. So your energy source is either a spring or a weight. It has a reduction. But the interesting part is this one. And this one has a German name. It's called Unruh. And Unruh means Ruhe is the silence, and Unruhe is the not silence. Because it's never silent. It's always like click, click, click. And this is what makes the click-clack noise of the clock. And so instead of without this wheel would just like spin and over. But this one, since this is the pendulum, and the pendulum could be the big swinging one, or it could be one with a spring. And so this keeps your clock from just winding off in an instant. So each time the pendulum comes, it pushes this into another direction, and you go one step further. Yeah, if you're interested, have a look. It's very nice. And okay, I think this is more or less my ideas. But think of think of stuff that is broken on your computers, on your cameras, on your electrical connectors. This is all things we can mold and cast, and they're small. So I'll export my actually, I should check the size, because now we're getting to the point where size is important. Okay, I'll show you first with the Fab modules, and then I have to show you on this computer, because on Windows my screen doesn't work. I can try. If it works, I'll show you here. If not, I'll show you on the other computer. So I open my STL. here it is. You can move it around and have a look. Then output format is RML. And I think we're going to make most of the ones on those two machines, and we can keep one if somebody needs to make a circuit or something. Then, so our machine is the SRM20. Don't forget to put the zeros. And I will reset, or actually I have to reset the view. Oh, bummer. I think if I tilt it, it's gonna make the model tilt. I just leave everything in 0. Then I say calculate height map. And what this does, it creates a grayscale image where everything that is high up is white and everything that is far down is black. I chose, haven't, whoops, what happened now? I think it should show something on top if it was working.
For the limit we show from the process tree, we don't choose anything from that process tree.
Yeah, we do. We choose, first we choose wax rough cut. And in this case, Neil does everything with 1/8, which is the 3mm mill. And yeah, if you choose something like where it's easy, then this should be enough. And let's see if it calculates like this. No, I should calculate the height map first. I think I have to be in Chrome. Oh. Come on. Oh, there it was. You saw it? Damn it. Yeah. Calculate height map. Okay, you know why it takes so long? Because this is my size. So I should put 25.4. Yeah, this. Yeah, here you have to put the conversion to inches. If not, it will create like a huge map that will crash your computer. Okay, so this is our height map. And this is actually a normal map, so it shows us also the direction of the normals. And then we can put the output format. Then I do process wax rough cut.
That makes you know how long you take before you.
In this software, no. Or I think, or maybe it does. So now you see it does layer 1, just the top. And then it goes down, so it's going to take a while. Tilt it a little bit. Let's see how it goes further down. yeah, this is quite boring, but from then on, it's just the same process than milling the PCBs. So you zero your machine on the top left corner, on top of your material. Maybe drill a little bit inside, so just in case you lose the zero, you can find it again. The machine always does a stupid surfacing pass that we don't really need. I know this isn't the Modella player. I think Alex wrote a post processor for this one, which is still half experimental. Ask him. Yeah, RhinoCam would be a good option. Actually, we could have a look if RhinoCam supports the Modella by now. Doesn't look like it. Yeah, I would recommend you the Fab modules, which is the easiest, and the other one would be one that comes with the Modella MDX20. It's called Modella Player. It looks a bit more like something you're used to, and I don't like it a lot, but it's usable. And if we had some time, should we just, like, there's so many, do you think it makes sense if I demonstrate this on the screen? Or should I try to get, oh no, our cable is huge. So maybe I can just, so I let this one continue calculating. Um, uh, oh, come on. Okay, let's go for the green version. Sorry. The problem is that this display only has HDMI ports and no VGA or anything. Or I could give it another try if I manage to get. Oh yeah, so this is the Fab. Sorry. Oh, come on. It's here. Oh, why are computers so stupid? Come on. It's here. So this is the results of the roughing pass in Fab modules. And then you would do the finishing pass. So it's wax finish cut. And with the tool overlap, you can adjust how do you say, the resolution of the model. So now I do a 90% overlap, so it's going to be quite coarse. But the smaller you make this value, the more lines it draws. And this one will only make, yeah, okay, it's in row 154 of 1,500, so it's going to take 10 times longer. But yeah, but this is quite edit-proof, and it like this one.
If you want it very precise, we do it like overlap 10%.
If you give it a try, you'll be able to see on your model how detailed it's going to be. And out of lack of a better solution, let's all look. What should I get a projector? Let's have a look at the screen. Okay. Let me put some chairs around. Bring it all there. Oh, it's just here. This one. And of course, you could take a smaller tool, but then it's going to take longer. And you only need it if you have like small details. Should I quickly show you the trick that I showed? Yeah, I feel like I should do this. I know it's 7 o'clock already. Maybe I should just quickly show you how to use the player, and then it's good. I will. I can give you a copy of this program. I will put it in the chat. And it's called Player. And it comes in 3 files. So you have the base version, then update to this one, and then update to this one. And you have to rename it. It's a bit annoying. So you open your file. And then then you go set the next view. But actually probably has but I remember like 3 meters square on and it's not in the video. I'll show you where you started the prototype, and it just gives you a choice of tools depending on the period you choose. So I'm going to use the modeling maps. And the very first thing shows you the size of the model. So we give you double check the size is right. And you want our origin to be this model. And then this one gives us the choice of like doing multi-side video. And this one, and you see now it's here. If I would choose middle, you would have to choose, you would have to find the center of the piece. Or you see here, you would have one, and you could have it and you limit that. That's the goal. And then we decided a new process. This would be working. Servicing is quick because it always has servicing, even if you don't want it. It's kind of annoying because you try to half an hour just watching the machine without touching the material. So if you want to accelerate it a bit, then you set it, you turn on the spindle, and instead of just touching the top surface, you go moving it to start. But at least you do it more satisfying. You are not in that. There's nothing in there. So this is how much we go back into our acting tool and go to our 2 meters squared. Actually, it's 3.175. Create your own tool. Actually, we do this by making a tool. And which is called 5. Squared. You also have round ball ones. Then you have a square and you can do a square you want. With diameter is 1.5. And then I can choose my configuration. And set parameters. And here you can either just leave equal settings because you can increase up to 200%, or I think 20 should be. Yeah, 20 should be fine. And talking to you once you we set a number between 7,000 and 7,000. Great. Okay, I'll just say, come on. There's nothing, there's no concept. Cube that I can't edit, and then you have to edit another one. Say, okay, I see that no material. Okay, so I can move to this screen.
You want to fight? You can turn it around.
Okay, so here we got it, and this one is already fixed. Make sure again the right machine, and make sure that I have references millimeter. And here the origin is in the front left corner. And we want to shade. Okay, so now we have the same plot. I go to new tool, roughing, a new process, roughing, and I choose my 175 square that I already created. And then we go back. So we can export those from there. And here you could send, if you go to partial, you could tell it that you only want part of your one machine. But if you make all those things in the right size and all is in one, you could also look at it from the side view and tell it, oh, actually, let's say you don't care so much about the wall, so you could, but let's just do it all. There are some tricks where you can save some time defining regions, but to be honest, it's very, like, try to define a useful region by moving those points. Like, almost impossible, you can zoom in, but it takes a day. You repeat all in most cases, and then in the roughing, I want you to do contour lines after, and then here the speed is okay. 24, 10, I will see if we can go deeper. So now the roughing, and this is true for those machines as much as for the shop block. And the roughing is mostly defined by the cutting inner mouth. And in this material, with a 3 mm build, you could do a cut in of 5 mm. Not a problem, it's still running at full speed. The problem is you need steps that are 5 mm high. And let's say you have a wall like this, it will transform it into steps and look like this. Then for the finishing, your 3 mm or your 1 mm tool runs into those high steps, and it's not going to like it. So if you know that you have 5 details and you want to use a thin tool in the finishing step, don't make your roughing too rough. It's a compromise. Like, you save time on one hand, but then you run the risk of breaking the tool again. So I would recommend something like 3 for the rough. But if you're doing all of something like 2 to 3 should be good for the roughing. And pass interval, this is the step over. Everybody remembers the step over? This is how far your tool moves to the side when it surfaces on every. So you do one line, then you step a bit to the side, and you go back, step a bit to the side, step a bit to the back. This is what it is, and what also the setting for making it high quality is not the high volume. And normally you would want something like half of your diameter. If you're in a hurry, you can use full diameter. You can express this in percent or in millimeters. You can go higher than the size of the tool. And if you want nice quality, you make it very small. And for the button, you need it quite big. So 1.8 for 3 mm build is quite good. And 25 or 24 is a good speed, you can still increase it. So, when you go back, give it a name, and finish. And this will generate our wrapping task. And then for the next step, then we do the finishing task. And make sure that there's no bumps left. Once it's finished, you can look at the simulation. Right? And if you have, try to keep your model as low polygonal as possible. If you put like a 20 megabyte STL in there, it's going to take a day. Depends on the amount of polygon. The second one is the distance from here to over there. the smaller the number, the less you set over, the higher your defect. And here you see that I did everything wrong. I don't have my 3 mm distance to the wall, so I'm going to break my 3. And if you want to have a preview, that is this one. And before you can preview, you have to go to those settings. So if you want to set your view location anywhere else than in the bottom left corner, then you would have to move your machine to the spot and set the new view position. And now this is the preview. And the model. So this is what the preview would look like. And these are all the spots where it would be. If you close this one, it asks you to save, but don't. So if I want to change those parameters, I can say, okay, cutting parameters, maybe by cutting them off is just 1. Then you have to retype it. Now we're going to see more steps. Step down, okay, that's smoother. Like, remember the little statue of this? This is kind of what you want to run. Yeah, this one can create but you could do it in the shortcut using the mobile cam. Okay, so this would be another button. And then we can click here. Because the small wheel would fit here on the floor, it would go all the way from the left to the right. And this is exactly what it will do. But going through there, suddenly it encounters like 2, 4, 6, 8 millimeters of solid wax. And this. So keep your distance from the wall. Not to better. But that's why I tell you to keep 3 millimeters distance from the wall. No, I mean distance from the wall. From the model to the wall. Making sense? Should I show you here? It's super easy. Like if you measure from, look, if I make a 3 millimeter cube,
You mean this little distance?
yeah.
Okay.
So I make it. Like, does everybody understand which distance I mean? Like, you know what I mean? Like, if I say this distance should be 3 millimeters, this is here now. Okay, so back to this one. So my next step is the finishing. And this is the square, so let's take the 1 millimeter square. So actually we have 0.8, no? Well, it's almost 0.8. But let's take this one. And the whole thing. And now this is going to save you a lot of time. If you say contour lines, and then optimize the pitch, you're going to save a lot of time. Yeah, you can listen. Yeah, so let's see. And here the cutting in amount is just 0.2. You don't want to go, maybe I could go max a millimeter, and have interval I want to keep it slow and keep it small. You could also do contour lines or scan lines the way the FabAcademy models do it, but this is going to take more time. You can do a comparison between the two. Okay? And you see that there is no blue lines anywhere in the middle. It just goes straight see that the small one goes along here. It goes straight all the way down to the floor. This is not a very. Definitely too close to the wall. Want to avoid those. If I click on here, it says the time time, so this one is just 20 minutes. Say we have 2 hours, 4 hours, or something. Yes, I would need a smaller tool. But here, where there's this and here, and okay, yeah, and so you do for understanding the roughing, you would click here on cutting, no cutting. So I can finish them off. And now if I click on this one, it will send it directly to the machine. And then you enable this one, disable this one, and enable this one for the limit machine. And you see that one is red and one is gray. So once you click send, it will send all the ones that are red. First, you just want to send roughing, and then you only send. You don't have to do it, just do both and make it 10 meters. This one was 20 minutes, and I guess the last one, so I disable this one. I think the model is quite small. I think it's 25 and 45. 40. Okay. Yeah, maybe we finish the vision on this one, then we complete the machines, and please save all the ranks. I don't want to throw anything away from the ranks. Look over there, there's a big bag. This is what's coming down from the bottom. I will prepare those and make room actually. And these bags ask me, I will put it and you can decide if you add a share. You don't constantly do it and take it out. But this one doesn't fit into the vacuum. So you would be better off cutting it. And you can also keep it just. And I will try to get the big dinosaur vacuum. Because it takes quite a while.
Which?
for SolidWorks installation. Cloud? For SolidWorks? Yeah. Cloud? You need a SolidWorks copy. Maybe I share with you. No. Okay. Yeah, that is the real thing. Yeah. I think. Right. There's a limit. Depending on the length of the wall. I it's part of it's part of oh, bam. Yes. No. Damn. What's the level of I could not make it. Okay.
Yeah, we didn't get to the SolidWorks part yet.
Make a mold.
Maybe.
Just make a quick mold and do the whole process, like.
No, once we have the first model, we can do the whole process together.
Okay, I must. Okay.
Okay, Greg, any questions from your side? Oh no, he's not there anymore.